Here we'll go over synthetic division. This is a form of division you can use in place of long division if you're only dividing by a first power term. Here we're given that x equals 2 is a real zero of this polynomial, 2x to the third minus 7x squared plus 12x minus 12. We are asked to use synthetic division to find the linear and irreducible quadratic factors. If you wanted to do this as a long division, you could start with x equals 2, and then as we did in the previous video, subtract 2 from both sides to get 0 on the right, and this would give you x minus 2 on the left. We could write that underneath the division bar here, and then change that into long division by writing x minus 2 on the left, and then place our 2x to the third minus 7x squared plus 12x minus 12 underneath the division symbol. However, note that this term we're dividing by, this binomial, is a first power x. If you do have a first power x, you can instead use synthetic division. To begin synthetic division, we're going to write only the coefficients of the polynomial on top of the division bar. We don't need to write the powers of x, but we do have to write them in descending order, largest to smallest. Also, bear in mind that if there are any powers missing, we will have to input a 0 for our coefficient. In our case, we will write 2, negative 7, positive 12, negative 12, starting from our third power and working our way down to our constant. Once we've written those coefficients, we're going to put a little box to the left, and in that box we will input our 0. We will not be entering x minus 2, we will only be entering the 2. Let's place a 2 in that position. We're going to begin by bringing down the leading coefficient. That's this 2 I've written an arrow underneath. We're going to take that leading coefficient times the box number. Once we found what that is, we're going to combine that with the next term in the chain. So we will take the 2 that we just brought down times the 2 on the left. This will give us 4. Then we will combine these two numbers, negative 7 and positive 4. Negative 7 plus 4 will give us a negative 3. Now we will repeat this process. We'll take that negative 3 also times the box number. Negative 3 times 2 will give us negative 6. Then once again we combine the terms, 12 minus 6. If we do that, we will get positive 6. Then we take that 6 we just got, again times the boxed number on the left. 6 times 2 will give us 12, and now negative 12 plus 12 gives us 0. Now that we've performed the synthetic division, our answer to that synthetic division is 2, negative 3, positive 6, but that will give us what's called an irreducible quadratic. The reason for this is because the last term in the chain, that 6, will be the constant term of our irreducible quadratic. The term to the left of that constant term will be the first power term, and then the term to the left of that will be the second power term, and if there were any more terms, you could continue third power and fourth power. We can say our irreducible quadratic will be 2x squared for our second power term, minus 3x for our first power term, plus 6 for our constant. The linear term that goes with that comes from the 2, which is in the box on the left. You may recall that we said that if we moved that 2 over, it would give us x minus 2. That x minus 2 will be our linear term. Therefore, below, we'll write that our linear term is x minus 2. Once again, we're calling this linear because the x is only first power, while we're calling our other answer, the 2x squared minus 3x plus 6, irreducible quadratic, because this quadratic is second power. Effectively, what we've done here is we've shortcutted long division to split our polynomial into a linear and irreducible quadratic. Previously, you've used techniques to factor quadratic equations. This is a technique you can use for higher power polynomials.